Hello everyone, welcome to Pure Math. We are starting with this chapter which is known as coordinate geometry, and we will be going through the basics of coordinate geometry. Now, what are the keywords that comes to your mind when we talk about coordinate geometry? For me, the two keywords are the axes, the horizontal axis, which is known as the x-axis, and then there is a vertical axis which is known as the y-axis. So coordinate geometry is about two axes, the story of two axes, that is the x-axis and the y-axis. And then naturally we talk about a point. Let's say the point is labeled by the letter Q and it has an x coordinate and a y coordinate. So we are talking about a point, we are talking about a coordinate, we are talking about axes, the horizontal axes and the vertical axes. The horizontal is known as x-axis, the vertical is known as y-axis. So now if I draw a line over here, a vertical axis and a horizontal axis. So let me label this as the y-axis, this as the x-axis. This point where the x-axis and the y-axis meet, that is known as O. O stands for origin. The coordinates of O are 0, 0. Because basically we start the counting in the horizontal direction, we start the counting in the vertical direction from O. So O is like the starting point. So this origin is like the starting point. When we go to the right along the x-axis, the values are positive. When we go to the left, the values are negative. Similarly, if we go up, the values are positive. If we go down with respect to the origin, the values are negative. That means, again, I have to draw a grid on and off. So therefore, this is the vertical axis, this is the horizontal axis. Let me label 4 points. So first of all, I'm labeling a point over here, that is A. I'm labeling a point over here, B, another point over here, C, another point over here, D. And remember, this is the x-axis, the horizontal axis. This is the y-axis, the vertical axis. Now let's say this point is 3 units. It's not drawn to scale. So let me write it down. It's not drawn to scale. So if this point, let's say, is 3 units away from the origin, therefore the coordinate of A is 3, 0. Why is it positive? Because it is to the right of the origin. So right of origin, O, is positive. Similarly, if we talk about the point C, let's say this is 1, this is 2, this is 3, this is 4. It's 4 units to the left. So this is left of origin. That is why it will be negative and the coordinate will be written as -4, 0. Now someone can ask this question, why am I labeling the y coordinate as 0? Because when we are moving along the x-axis, there is no increase or decrease in height with respect to the origin. I'm not going up, I'm not going down, I'm moving along the x-axis. So remember the keyword along x-axis, the y coordinate is 0. Because the height is neither increasing nor decreasing with respect to the origin. Similarly, if I talk about point B, so this is 1, this is 2, this is 3 units up. So this is top of the origin or upwards from origin. So that is why this will be positive and the coordinates of B would be 0, 4. Similarly, if we talk about the point D, 1, 2, 3, and 4, it's 4 units down. So what are the coordinates of D? The coordinates of D are 0, -4. Why is it negative? because now we are going down, we are going below the origin. So when we go below the origin, the y coordinate is negative. So some basic things which you have already studied in basic maths. So we are just going over that. So now we are talking about this idea, and again it's time to draw the axes. So that's the y-axis, that is the x-axis, and then that is labeled y and x and the origin. Now if I label a point over here, let's say Q, and the coordinates of Q are 3, 4. That means we are moving 3 units right, we are moving 4 units up in order for us to reach from O till Q. So basically, the movement along the x-axis, that is 3 units, that is the x coordinate. The movement along the y-axis, that is 4 units. The diagram is not drawn to scale. So if someone is starting from the origin and someone is walking 3 units right, 4 units up, it will reach the point Q. So now you have a feel for it. That coordinate geometry, I'm using the symbol CG. Coordinate geometry is about direction on a grid, and it's a 2-dimensional grid, and we can go right, we can go left, we can go up, we can go down. Right is positive, left is negative, up is positive, down is negative. So that is how things are going. Now, if we talk about the concept that if I take this thing and let me draw an orange line going to the right, and let me draw a green line going up. Again, the diagram is not drawn to scale, and then a blue line connecting these two. Now let's say this is the origin, and we are going 3 units right, we are going 4 units up. It's a right angle triangle because this is horizontal, this is vertical. Now this distance from the starting point till the end, how many units is this? So we can apply Pythagoras theorem. We can say OQ square is equals to 3 square plus 4 square. That is 9, that is 16, this comes out to be 25. But remember, this is OQ square. So how much is OQ? That is square root of 25, which is 5 units. So basically, what I have done is that I have found the distance from this point, which is O, all the way till this point, which is Q, which is 5 units. So if we break it down into a horizontal component and a vertical component, that's 3 right and 4 up component. So now this is 3 right and 4 up. That's how it's going. Now let me make it more generalized. Let me again draw a line, and let me increase the thickness of this thing. So my line is a bit thicker, I hope so. And that's how the line is drawn. No, it's not getting any thicker. This point is A, and I'm labeling it as X1 and Y1. And this point is B, I'm labeling it as X2 and Y2. Now, if we talk about this thing, and let me draw a horizontal line going this way, that is going from here all the way till this way, and then all the way like this. So if I focus on the x coordinate, this is x1, this is x2. Therefore, the base is basically x2 minus x1. So base is x2 minus x1. Similarly, if I talk about the height, that is the difference between y2 and y1. So this is height is y2, this is y1, and naturally it's with respect to the origin. So let me draw the axes to give you the idea. So somewhere here is the origin. And we are talking with respect to origin. We have the y-axis, we have the x-axis. And this base is x2 minus x1. This height is how much? This height is y2 minus y1, the difference between the two y coordinates. And this thing over here, d, that is the distance between 2 points. So now how can they be related? I hope you got the idea. They are related using Pythagoras theorem. So let me write it down. So I'll write d square, which is basically the hypotenuse. So this d square equals to base square plus the height square. D square is equals to x2 minus x1 whole square, and this is y2 minus y1 whole square. Therefore, d, the distance between 2 points, is this bracket squared and this bracket squared, and don't forget to put the square root. That is how we get the idea of distance between 2 points. So now we have reached the stage. So now let's draw a diagram, draw a grid, which you always will see me drawing, because it's all about the grid. Without the grid, you won't have any idea. So again, y-axis, again the x-axis, there is the origin, there is a point, let me label this point as A, and then there is another point which I'm labeling as B. So let me write down the coordinates of A. It's just a rough diagram. Let's say 3, 1. Actually, let me make it 3, 2. And then I have B, so let's say this is 7, 6, something like this. And I'm interested in finding the distance between these 2 points. So if I join it with a line, that is what I'm looking for. And if I break it down horizontally, I'm going this way like this, and then this way like this. Keep in mind, the diagram is not drawn to scale. So if this is 2, actually this is 3, and let me use the proper color, the orange color. So this is 3, and this is 7. So the difference between 3 and 7 is 4 units. And let me just do a small change. I'm grabbing my eraser, and let me just erase the 6. And instead, let me write 5 over here. So I'm writing a 5 over here. So now the height, this is the difference between 5 and 2. This is 3 units. I just wanted the numbers to be a little bit friendlier and nothing more. So now if I connect these two, so this is 4 units, this is 3 units, this is the base, this is the height, this is the distance between A and B. Isn't this something like this? Not this one, this one. Yes, it is exactly the same. So therefore, if I calculate the distance between 2 points, so that is 4 square plus 3 square, square root, 16 plus 9 square root, that is square root of 25, which is 5 units. So therefore, that is the distance between 2 points. Now, can we use the Pythagoras formula? We are using the Pythagoras theorem. So this is Pythagoras theorem. And the question is, can we use this formula, which I just mentioned earlier? Let me pinpoint it to you. Yes, this is the formula that I'm talking about. And let me draw a box around it. So no, this is not the box. The other one is the box. That is this one. Yeah, this is the box. So let me draw a box around it. Can we use this formula? The answer is yes. So let me write down the points. So the working should be over here like this. And the first point is A, that is 3, 2. The other one is 7, 5. So this A is 3, 2. The other one is 7, 5. And the magnitude, the distance between 2 points, I can also say this is, let me first write it down. This is length of line segment AB. So this is the difference between the x coordinates, which is 3 and 7. So 3 minus 7 whole square. It doesn't make a difference if you write 7 minus 3 whole square, because anyway it's going to be squared. And then the other one, the difference between the y coordinates, which is 2 minus 5, the whole thing square, and then put a plus sign, put a square root, This you already know. 3 minus 7 is negative 4. Negative 4 square is 16. 2 minus 5 is negative 3. Square is 9. So this is exactly the same thing as before. So therefore, this is 16. This is 9. Square root of 25, which comes out to be 5 units. So that is the kind of basic question that we come across. Right now, I'm not going into examination question. Let me explain the concepts in a very clear, concise manner, and then we will go to those questions. So I think I'll just stop over here. And this is lecture number 1 of coordinate geometry, in which we talked about points, we talked about x's or plural is x's, we talked about positive, negative, and we talked about right, left, up, down. We talked about Pythagoras theorem, and we talked about the distance formula, which is distance between 2 points. It's derived from Pythagoras theorem, and it can also be termed as length of line segment AB. This can also be termed as magnitude of this line segment AB. So let's stop over here and then see you in the next class.